Now next chapter is isometric projections. Most of the students find this chapter difficult and mostly keep it for option because it is totally depending on your imagination. You can solve this problem. In other chapters, you are having some predefined procedures by following which you can get the solution. But here, those procedures cannot be generalized. But if you observe the question carefully, and if you instead of drawing the entire solution at once, if you divide that particular diagram into small parts, and if you solve this, then we can still generalize the procedure for this particular problem of isometric projection. And there will be two questions asked, one for 6 marks, which will be easiest one, because it will not mostly will not contain the curve paths, curve portions, which are circular holes on either a flat surface or curved surface. So it will be just made up of flat planes or inclined planes. But for 9 marks, that question will contain either a throughout hole from on a flat surface or a curved surface. So we will first start with the simplest one, 6 mark question. Again, there will be two types. In first type, front view and side view will be given. One of the side view, either right hand side or left hand side. In this particular problem, front view and left hand side view is given. And the second type will be front view and top view will be given. So for completing the isometric projection, you at least need two views, either front view or side view, anyone, either left hand side or right hand side, or front view and top view. So if front view and left hand side view is given, so we will generalize one procedure for that, and if front view and top view is given, then we will generalize one more procedure for that. So here, if you see in front view and left hand side view, there will be one dimension which is common. Since it is a three-dimensional object, so obviously the three dimensions which I am going to get are length. First is length, then height, and width. Okay, so if you see, I am getting the length in left hand side view, which is 100 maximum size. Okay, then it is not always necessary that you will get length in front view, because if you compare length and width, length will be maximum. So the length you are getting in left hand side view, then maximum height is 70. Okay, this dimension will be common for both the views, front view as well as left hand side view. So height is 70. I am writing in between because that is common for both the views. And then for width, I have to look in front view, which is 80. Here maximum dimensions are already given, but sometimes to get the maximum dimensions you need to add 2-3 dimensions, but in this question all the dimensions are directly given. Now obviously, if these are the dimensions for length, height and width, so I know that the entire three-dimensional object can be placed in a box which is having these dimensions. So I have first drawn that box, already drawn, to save the time. So here in this box we are having one dimension as length, which is 100 mm, and the convention for drawing this box is, so the procedure will be, first you need to mark a horizontal line, then you have to fix a origin O. I'll tell you how to mark this origin. Then on one side of this origin you will mark 30 degree, then second angle will be 90 degree for marking height, and on the other side you will mark again 30 degree. So these angles are 30 degree. Okay, so on this side, on this 30 degree marking angle, you can either cut length or width. That will depend on direction, that position of the observer, from which direction the observer is going to look at the object. Then again on this 30 degree, it can be either length or width. We will see for this particular problem which will be marked here. And then height will be, it is given 70, so I need to mark 70 on this first. After marking 30, then 90 and 30, on that vertical 90 degree projector I will mark 70 height. Okay, then now we'll see where to mark length and where to mark width. Now if you see, the front view and left hand side view is given. So if I, by trial and error, if I decide direction of observer, suppose if I say this is the direction of observer, okay, so then the observer will look perpendicular to this particular plane, but here on this plane he will be getting front view, but on this plane he will be getting his right hand side view, because if I am the observer, I am looking from this direction, then this view will be my right hand side view, okay, but in the question the given view is left hand side view. So obviously my assumption for front view was wrong initially. So now obviously to fix the direction of front view, observer has to look from this direction. So now if you check, if I am getting front view on this particular plane, which is also called as right plane, okay, so obviously the view on this plane will be left hand side view, because it is the left hand side of observer. So accordingly I need to decide where to draw the front view and where to get the left hand side view. So in that case, here since front view I am getting width and not the length, because width is 80 less than 100 mm is seen in front view and length 100 mm is seen in side view. So I am marking the width on the right plane and marking the length for left hand side view on left plane. So now after marking this 100 mm and this as 80 mm, again at the endpoints of 100 and 80, I'll again draw vertical projectors to mark the height again 70. So till now we have drawn these 1, 2, 3 lines, then again marking 100 and vertical projector, I'll again cut 70 mm here, again on this vertical projector I'll cut 70. So now from this point to this point, which is this 70 height and this 70 height, I'll again join from this 70 and this 70, okay. So this has given me the entire right plane on which I am getting front view, and this entire plane is the left hand side view. So left plane, okay, the entire left plane. Now obviously after combination of front view and left hand side view, I'll be getting the third view, which is top view. So if you see here, I have already marked this width and length, okay. So height obviously will not be visible in top view. So with this width and length 80 and 100, I'll complete the top plane. So obviously I need to draw a parallel line to this width, which is already marked. So I'll mark at the height of at the length of 100. So I need to move this side by 100 to mark this parallel line. Again, to transfer this length along the width, I need to move parallelly by 80 mm. So I'll complete these two lines to complete the top plane. So now this has completed the that box in which my entire three-dimensional object can be placed. So my object is obviously not going out of this box. Now after this, as I said before, this plane which is called as right plane, and on this right plane I am going to get the front view, okay, and on this left plane we are going to get left hand side view as per the direction of observers. This is the direction of observer. So I have generalized some method to solve such problems. So that method is, I'll divide the entire question into small parts, okay, which are having equal heights, because the common dimension between front view and left hand side view is height, okay, and those parts should be closed loop parts. That means if I start from bottom, then if you see this in front view, this part, and obviously this height for that part is not given in front view, but that height is given in left hand side view, so it is having the same height. So I am having the height of that part as 10, and obviously it is closed, and corresponding to same height of 10, I am getting this part in left hand side, okay. So I'll combine these two to get a three-dimensional view for these two corresponding views. Okay, so I'm going height wise starting from bottom. So first height I've chosen is 10. Okay, then we will see which is the next height. So next height, if you see, it is 40. The next light, that next line I'm getting on height of 40. So again I'll see the next part. So this is the closed structure again for height of 30. So now I'm moving further from 10 to 40. That means I'm moving to next height of 30, because 10 we have already covered in first. Then likewise we will go height wise up to top. So now if you see in the question, here something extra data is given apart from dimension, that is O. Now what do you mean by O? So in the box where you have started measuring all the angles, this 30, 90 and 30 again, that will give me the origin. Now with respect to this origin, I need to place these views on the corresponding planes. So obviously if I want to get the front view here, so my front view will be, origin will be here, so that rectangular strip I'll be able to see here, that 10 mm height, and then correspondingly that this bigger part will be seen from this boundary of the rectangle, okay, not from here. So this, the significance of origin is to decide the order in which we are going to get the front view. Okay, so you should not draw this view here. I should start from this end because origin is here. So I'll go in this direction. So this particular plane, this particular entire front view, which is now a flat surface, okay, I need to tilt this entire view on a 30-degree inclined plane, keeping this O coinciding with this origin. Similarly, if you see the left hand side view, the origin is given here. So again the method is to incline the entire left hand side view on this left hand side plane. So with the view which is flat now, I need to just incline that entire view on a 30-degree inclined plane, but keeping this O coinciding with this O. So this line will be seen like this starting from the origin, and I'll not get this line from the origin but this line from the origin. So the significance of origin is to decide the order of drawing those views, front view as well as left hand side view. So now as per our method, as we have divided the front view and left hand side view into small parts of that heights in increasing order from bottom to top, so we'll start with only those parts. First I'll start with only 10 mm height part, which are marked with the hatching lines. So if I need to draw this rectangle, obviously the size of this rectangle, if you see the dimensions, this small part, obviously I'm getting height as 10, and if you see the width, it is 20 plus 20, so I'm getting 40. So for redrawing this front view on an inclined plane, so I'll be getting front view on this plane and left hand side view on this plane. I need to start with the origin, measuring the height 10, and then along the width I need to measure 40, not the entire width 80 but 40, and then I can complete this rectangle. But if you see corresponding height in left hand side view, I am getting this rectangle which is having dimensions of 60 by 10, but if you see here, that rectangle is not starting from origin as that of front view. So I need to start marking this rectangle exactly from the opposite boundary of the origin. So I'll redraw that rectangle of 60 by 10 in left hand side view on the left plane but inclined at 30 degree. Okay, so we will start with these two parts of equal heights, and for that I'll just redraw those front view and side views on those corresponding planes. Front view on the right plane and left hand side view on the left plane. Obviously we are not drawing the entire front view and entire side view at a time. we are going part by part. So first I'll draw this rectangle starting from origin, which is 10 by 40. So first along the width I'll mark 40, and these lines should be light lines because these are not the final views. I'm just doing this procedure for getting those final views. So I'll mark the height of 10, and now that straight line will become inclined because that plane we have made inclined at 30 degree. So be careful while drawing the parallel lines. Okay. So you have drawn this front view rectangle of height 10 mm. Then corresponding height 10 mm I'll draw in left hand side view, but not starting with the origin, but exactly from the opposite boundary from the origin. So I'll mark that common height 10 on this boundary of the rectangle. Then I have to go along the length now by distance of 60. Okay, now I'll measure 60 along the length from that boundary. Okay, and I'll complete that small rectangle on the inclined plane, which is left plane. Okay, now using these two views of rectangles, I'll get a three-dimensional object for this particular height. As we have studied in solid projections of solids, if the two views are rectangle, okay, obviously if you are having this front view and side view, so you know the three-dimensional object should be a prism like this. Then only you'll get front view as a rectangle or a square. If it is square prism, top view will be square, but I'll get front view and side view as rectangles. So here again we are having rectangle, so we'll get a prism. Now how to get three-dimensional view, that is the isometric view, after using these two views? So the procedure is, whatever are the number of corners here, so if you see the part is having 4 corners, this rectangle, okay, and we have marked along the length this particular rectangle. Though as per my procedure, we should produce these corners now along the width, okay, because we have already marked along the length. So now I am going to produce these corners, projector from each corner along the width, and similarly this rectangle we have marked along the width, so again having 4 corners. So from each corner now I will produce along the length, and where the projectors from this view along the width and this view along the length intersects, that will give me the intersecting points, and after joining those intersecting points I'll be able to get an isometric view for these two side view and front view. So using that method, if you see, for drawing those projectors along the width from the lengths we have already marked in the side view. So I need to start with this edge boundary of the rectangle, which is the outer boundary. Then using that reference, I'll draw the parallel lines from each corners. Now again, we need not produce along the entire width. I should produce along the up to that width for this particular part. So since it is having only width of 40, so I should produce this width, this side view along the width only up to 40. but we are not measuring, so we will approximately produce. Okay, because intersection from this front view along the length will not be going along beyond 40. So I'll just produce approximately 40, not more than that, from all the corners in the left hand side view. Now after producing this length along the width, now the same height I'll produce width along the length. So for that I'll take the reference of this boundary, which is the length, and if you see, projector from this corner is obviously coinciding with this initially marked length on left hand side view. Again, if you see this corner, again it is coinciding with the boundary of the box. So I need to move further to this corner. So I'll produce, and again this corner I need to produce. Now I am producing up to the entire length, because this part is starting from the opposite boundary, means extreme boundary of the rectangle. So from these corners along the width, I need to produce along the width for entire length, because I need to reach up to the opposite boundary of the box, because this part left hand side view is starting from that boundary. Now after doing this, at 10 mm height, whatever are the projectors, means corners, from these corners, they will be intersecting each other. So I will mark those points first, because that intersection will give me the top view. Because base, which is starting from the bottom, if I join those four corners, that will become the base and will not be visible to the observer. Only top will be the top of those intersections will be visible. So I'll mark those points which are at height of 10. So projector, these two projectors at height of 10 and these two projectors at height of 10. So those will give me these four intersecting points. Okay, and if I join those, I'll get the top view of that corresponding front view and side view. So for this corresponding front view and this corresponding side view, I'm getting this rectangle as a top view. So you need not make it initially dark, because it may or may not be retained after drawing the next small parts of the next sides. Because if you are keeping some object of more height on this top, then some of the parts of this top view I have to erase. So initially I will not make it dark, so I just keep that part which is visible to the observer. If you see, now if I am joining to get the entire view, so I'll get, this is also part of that, and again the intersection here, so I can join this vertical, means this rectangle actually I'm shifting inside to get this rectangle. Okay, the projection I'm getting on this plane, but actually in that box the location of exactly location of this plane, this rectangle is not on the boundary of the rectangle, but it is inside. So this will give me this actual rectangle here. Okay, now if you see, I have marked only some lines dark, because if you see, projector from this corner, observer is not going to see this part, because this line is not visible to the observer, because this plane will be visible first, and whatever is behind that plane is not visible to the observer. Similarly, this plane will be visible, and obviously line passing through this will not be visible. So I'll erase those lines, because those are not visible to the observer. I have drawn all those lines because I need a generalized procedure. So we are drawing those projectors from each corner, not leaving any corner. But by practice, you will learn which projectors from corners you should draw, and which you can omit. So for these two corresponding rectangles 1040 and 1060, we have got this particular shape. Now after drawing the three-dimensional view for next height, I will not be able to see the entire this prism as it is, because after adding some part of more height, some of the base may get blocked due to the preference to more height. So now we will move to the next part. So before that, I'll erase the initially drawn parts to avoid the confusion, because if you keep those lines as it is, and if you draw the next part keeping the projectors, then you will be confused because many lines will be there. So after finishing this for one height, now I'll move to the next part of next height. Okay, again we will draw that view on those planes. So first front view on this plane and side view on this plane. So now I'll move, after finishing this part, now I'll move to the next height. So above 10, I'll look for closed loop, means closed structure. So if you see from 10 to 40, means this 30 height, in front view I am getting this shape. So I'll be redrawing the same shape as it is on this plane, but on an inclined plane, not on a horizontal plane. Again, corresponding to this height, I am getting this closed loop, this closed structure, which is again, this height will be 30. Okay, so total will be 40. Now you are reaching up to height of 40, starting from bottom. Now we'll start redrawing this shape, which are shown by hatching lines. So again we need to consider the position of origin for that. So from where I should start drawing these two. So obviously for this I'll again start with this height. Okay, then I need to keep that initially drawn line because one line is common. So we can draw that line again. But now if you see this length is again 40, so at 40 I am getting a vertical line, so I will be getting a parallel line passing through this point. So I will draw a parallel line of 40. Okay, but this for this part, though this line is continuing further, but I am drawing for only for this part, so I need to go only up to height of 40. So first I'll draw and then I'll measure. So from above this point I need to measure only 30 because 10 is already considered here. So I need to just mark 30. Okay. Now we have reached to half of the width 80, but if you see this point, it is only at a distance of 20 from the origin. So again, at a height of 40, total height of 40, I'll come towards the origin, passing through this height of 40. Okay, and inside I need to come by a distance of 20. So I'll again measure from here, and the distance should be 20. Okay, now I'll join this point to this point, okay, to get this particular part on the front view plane, which is right plane. So we are just tilting that plane on an inclined plane by taking the dimensions. Now I'll draw the corresponding height, means this part, on left hand side plane, which is this plane. So again for that, this initially drawn line is base. Now I need to start this drawing inclined line from this point, but I don't know the angle for that. So first I have to mark this 30 length from the opposite boundary at a height of 30. So I'll first go above this 10, I'll go 30 more. So I'm getting this point. Okay, and from this point I need to come towards center by 30. So I'll first draw a parallel line from that height to the length of the box outer boundary. And I have to measure 30 mm because this length is given as 30. So I'll come 30 here. Okay. Now we'll join with this corner to get this point. So we have marked those two parts of further heights which are 30, 30. Okay. And lengths are again 60, it is covering 60 and it is again covering 40. But height has increased from 10 to 40. So now we will follow the same procedure as we have got 1, 2, 3, 4. Okay, 4 corners. Again here 1, 2, 3, 4. So we'll drop the projectors from each corner. Now these corners are along the length. So we'll drop the projector from these corners along the width. Similarly, for these 2 points, I'll drop the projectors along the length. Okay, and if you see the bottom 2 corners for both the views, the projectors from those are already drawn. So we'll first mark the projectors from the highest points to get the top view, because projector from the maximum height will give in the top view. From the bottom you need not draw those projectors because that view may not be visible to the observer. So first preference I'll give to the highest points, projectors from the highest points, because that will give me a top view which is obviously visible to the observer. Again, no need to produce along the entire width, because if you see this part is only up to 40, width of 40. So but these 2 corners along the width I need to produce up to entire length, because it is again starting from the opposite boundary of the rectangle. So for these 2 corners I'll go up to the entire length, maximum up to this projector. So for this I'm going this. So now if you see the intersecting points for both the projectors from here and here, I'll get these 4 intersecting points, right? And this will become my top view for these corresponding heights, means height of 40, and obviously that top view will be visible to the observer. So I can make it dark, not permanently dark, but still it may change after drawing the next height. So but still you can make it dark. Okay, now we will see what to do with these bottom corners. Okay, now if you see, I should get inclined line view in the front view starting from this corner. So I should get an edge in actual 3D view, okay, which is inclined line, and will give me this as an apparent front view. So obviously this point I can coincide here, and if I join this line, now here your imagination part comes. So this line, after projecting on this view, this plane, I'll get this line. Okay, but similarly for this vertical line, since it is vertical, I have to shift that line, because if you see this line is already shifted here, so this height will be shifted from this corner. Okay, but it is appearing here as a vertical, but here I can't draw it vertical, if you see, if I draw it vertical, it is not touching any corner. It is intersecting the side, but it should meet with some corner. So obviously, if I am drawing it with this corner, okay. Now if you see, if you project it on this plane, so this particular inclined line will be appear as a vertical line. So this is the true length and this is the apparent length in front view. Okay. Again, similarly, you have to see for, okay, and this is the apparent view in front view, but for same inclined line, I am getting true length in side view. If you see this side view, inclined length, you will get same inclination from this corner. So what I am doing, I am shifting this inclined line at a width of 40. Okay, so I'll get the same true length in left hand side. Okay, so now we have finished with this corner, this corner, this corner. Okay, now we have left with this corner. So we have to see whether should I join a vertical line or inclined line. Okay, obviously if you see here, this line is giving me apparent length for this line, but if you see, if I produce it parallelly up to this corner, it will give me exact corner to corner joining line. So obviously this line will give me true length here, okay, but for this particular line it will give me apparent, because it is on the same at the same height, at the same width inside. So I am getting two lines for a single line projected in front of you. So this line will be repeated twice to get this view. Again this line will be repeated twice. So first line is this inclined line will give me this apparent view, but second line, obviously it is not visible here, will start from this corner, will be joined to opposite corner. But since observer can't see the line behind, so we are not going to show that line. Again, base the top of that plane, initial height 10 mm, which we have drawn like this. Now since this part has come above that top base, so obviously these two lines will not be visible to observer now, because those have gone beyond that, behind these planes, this particular plane and this particular plane. So these two lines will not be seen to the observer. That's why I told initially that don't make those lines dark. So now I'll erase everything except the visible parts, because it will create the confusion for taking next heights. So first I'll erase the initially drawn part which are now not visible. Again the projector is passing through that view. Sorry, it is the boundary of that box, so should not erase that. Okay. If the boundary is passing through that view, it does not mean that we have reached up to height of 70. This height is below 70. Okay. Now I'll again erase those parts to avoid the confusion, because those parts are already used for getting the corresponding views. Because after drawing the next view again, we'll get more projectors. So that should not create the confusion. So that's why we are erasing the initially drawn parts. Now for next height, if you see, we have considered the two closed parts. Now for this particular height of 40, we have considered only this closed structure. But if you see, this part is again starting from bottom and it is covering the entire height. We have not considered that part yet, because we have already got the closed structures. So we are only considering the closed parts. Now, if I want to consider this, so I'll go for this part, this entire thing, because it is again starting from bottom. Okay, so this entire part, so this corresponding height, which is now 40 plus remaining is 30, out of that this is 15, so this height will be 15. So now we'll consider the next height of 15, but for this part it will be the entire height, so I am going to consider now here at this particular height I am having a closed structure in left hand side view, but there is no closed structure for remaining part because these two are already used. So for my convenience I'll join a extra line here which will give me a closed part. Okay, we'll see what to do with that part later on, but for making it closed I'm assuming there one line that will make this closed rectangle. Okay, so now the parts I need to redraw on these corresponding views are this first is this rectangle from front view, and corresponding to that I'll redraw this part in side view. So first I'll draw that rectangle in front view. So that rectangle will start with from the bottom, so and up to height of that height is 45. 40 plus 15. Sorry, 55. So 40 plus 15. So I need to go now up to 55. Total height is 70. Okay, so at this height of 55 I'll complete this rectangle, so that's why I need to go to the opposite boundary, that means up to this. So I'll just produce one line to get that rectangle. So we are just redrawing the things on the inclined plane, but not the entire front view and entire top view. We are selecting the parts height wise, and that to the closed parts. So now this particular front view part is giving me this rectangle. Now the remaining part will come above that, but we will consider that in next height. So that remaining height should be 15. Okay. Now corresponding to this height, I should draw this line and this line in side view. So for that again, from the opposite boundary of the origin, I'll measure 45 height. 55 height. So somewhere here, and I need to measure this length. Okay, but this length is not given. So, but this inclination is same for this 40 mm length. So to mark this inclined line, I'll first mark this 40 mm length. Okay, and then I'll join from this end of 40 to origin to get this inclined line. But I'll just join up to this because next height we are considering only 55, not the entire 70. So first I'll mark this 40 on the topmost line, boundary of the rectangle, from the opposite boundary of the origin. So 40 I am getting somewhere here. Okay. Now to draw this inclined line, I should start with origin and I should go up to this line. But now I need not go entirely up to the top because next height we are considering only 55. So I'll first draw the line passing through 55. So which is this line, and I'll just see that 40 end point and origin, and I'll first consider only this much inclined line. Okay, the remaining inclined line we have this reference of 40, so we can just redraw that part of next height later on. So now we have considered this part This is the entire thing, and this rectangle of next height, which is 55. Now again doing the same procedure. First, to get the corresponding top view, I'll first produce these corners which are marked along the length. So I'll draw the projectors along the widths from those points. Similarly, I have the topmost points here which are marked along the width. So we will produce those points along the length. So intersection of from front view and side view projectors, I'll get the corresponding top view. So first I'll project from this point, then from this point. Now I need to go up to entire width because this rectangle has now touched the opposite boundary. So I need to go to entire width of the box. Then only those projectors will intersect each other. Now next I'll drop the projector from these heights, which is 55. Now from width along the length. Now projectors from these two and these two corners will give me this as the top view. Right? Now first I'll just mark that top view, but you should not make it entirely dark because some part is going to come above that also. So first initially we'll mark that not by dark lines, entirely dark lines, but of medium darkness. Okay. Now I need to decide where should I join all these corners with the view which is already drawn below, because those views should be interconnecting. Okay, these small objects are placed one above the other or alongside each other. So I need to see from these corners where should I join. So obviously I am getting one view in left hand side as a inclined line. So if I transfer this line, so I need to transfer this line along the width inside. Then only after projecting on this plane, I'll be able to see this inclined line as the side view. So obviously, I can either start from this, okay, and obviously this line is the actual line boundary of the object. After projecting in front view, will give me projection from this corner, and this corner is obviously coinciding with the outer space of the box. So this line is giving me the apparent view. Okay, this line in left hand side view is giving me the true length inside view, but corresponding front view is the apparent height, this one. Similarly, this will be redrawn again from the opposite corner also, because this height I am getting on this boundary also. So this will be repeated twice. So I need to draw one more parallel line from here. So we are getting two parallel lines. Okay. Now, so corresponding to these two inclined lines, I am getting these vertical lines in the front view, which are apparent. Okay. Now, for this height, we have already drawn this top view. Okay. Now, we need to join this corner, that is the base point, with the initially drawn part somewhere. So there should be interconnection. As we know, this is the entire thing for this height, 55. Okay, because we are having that part up to the bottom. So I should get this line in the left hand side view. So this line is actually not on the boundary, but we need to shift it inside, passing through this corner, and obviously it will join the previously drawn part. So actually this line is giving me this view, which is this view here, this line. Okay, so for the next 55 height part, my view is actually starting from the bottom, which is this line. Okay, so I'll be able to see this line here intersecting here, here and here. Those will coincide. Now we have covered this corner also, this corner, this corner. Now we are left with this corner. But if I draw a line parallel to this, as we have done for this inclined line, repeating it twice, but if I repeat it again for this corner, but obviously that is not going to be visible to the observer, so no point in drawing that. So I'm not drawing that edge because it is behind, not visible to the observer. Now we are left with these two corners. Now I need to check where should I join to the previously drawn part. Okay, if you see for this part, I'm getting a straight line on the boundary, and if you see this point is already on this boundary, which is this face of the rectangle. So I can just draw a straight vertical line joining with the previously drawn part. So this will give me this length here. Okay, again no need to draw this line. Actually, if you see the view drawn on left hand side, it is going up to the bottom, but this line, if I produce up to the bottom, but that will not be visible because this part is coming in front, so that line is not visible. So we need not draw that up to bottom. We should draw up to here only because only that part is visible. Similarly, if I draw the same line from this corner, obviously that is not visible to the observer, so we need not draw that. Okay, so now the view which we have got is this line, these two lines for the actual object. Then this line will be visible. Now this previously drawn, and again this. I'm not making the top that dark yet because we are left with some more height. Now we'll move to the next height, which is this portion in front view, and remaining in left hand side view is this portion which is closed. But in front view I'm not getting closed, so for the previous height we did some extra construction, which is this dotted line. So now we'll draw this part as well as this part. Okay, so before that I'll erase the previously drawn parts. So obviously this inclined line I don't need now because for next part only I need only this. So before erasing that, I'll just draw the remaining part because we have already marked that 40 distance here. So I'll just in continuation draw that inclined line. Okay, so obviously this part, because this is the boundary, will coincide here. So I'm getting this part, this trapezium for remaining left hand side view, which is here. Okay, so I'll now erase the previously drawn because this inclined line has already shifted inside. So now no need of keeping that on the boundary of the rectangle. So again we'll erase this rectangle, okay, which is this one, but I should keep this line because I'm getting trapezium above, so one base will be common. So I'll just erase this. Okay, and I'll erase the projectors from the top. I'll just keep the intersecting points, area under the inside the intersecting points. So we are erasing the initially drawn projectors to avoid the confusion, because if you get many lines then it will create a confusion. So once you have finished with one height, then erase the parts which are drawn initially, like projectors and those views on inclined planes. Now moving to the next part, which is this trapezium, this one. Which is representing the remaining height in left hand side with this part. Again corresponding, we have made one closed, again a trapezium. So for that I need to measure this 25 mm. from this boundary of the rectangle. So I'll measure first 25 mm to draw that inclined line. So from this 25 mm, okay, I need to go up to this width is 50, so which is already marked here, okay, which we have not erased from the initial previous height. So now we are getting this trapezium and this trapezium. So again the same method. First I'll project from the topmost corners of the project this trapezium. So that means this corner and this corner. Again this corner and this corner. Now if you see, from this corner we are already getting along the width the boundary of the box. From this corner along the length we are already getting one boundary of the box. So we need to just project for two corners. So I'll project this corner first, okay, then again from this boundary of the rectangle this corner. Now mark the intersecting points of these two projectors, which is boundary, again boundary, and these two lines. So I am getting this as a top view. Okay. Now since it is the highest top view, nothing is going to come above that, so it will be entirely visible to the observer. So I can make it dark, which we could not make for the previous top view, because some part is resting above that top, means this was the previous top view, but I'm not sure whether should I make it dark or not, because some part will be resting above that, but on this top view nothing will rest, so I can make it dark. Now I have to decide further that from these corners which corners should be joined from the previously drawn views. So first option is I can join this corner with this corner. Now for that I need to check the left hand side view, because for that I am getting this line. Okay, so if I join here from here to here, that will be an inclined line, but if you project in left hand side view, for that inclined line you will get this length, this height, which is 15 mm as an apparent view. That means for this inclined line I am getting this vertical line as an apparent view. So we have to join this. Again from this corner I need to join to this corner. Okay, so this will give me this apparent inclined line, because when I'm projecting this, it will be projected in front of you as this inclined line. Okay, now again for this height of the trapezium, this corner should be joined to this. So that means I can continue with the same inclination, because this is the vertical line here. So if I produce the same inclination, okay, this corresponding inclined line, the front view for that I'll get a apparent vertical line. Similarly for this line I'm getting this side of the trapezium as an inclined line in side view, and this for this inclined line I'm getting this line as a apparent view in front view. Now after completing this, if you see, this base means this line is visible in the left hand side view. So I'll shift this line from here along the width, and that will be visible. That means from the bottom base, out of these four lines, this line will be visible, which we have not made initially dark. But now if you see, after keeping this trapezoidal part above that base, this line is still visible to the observer. But if you see this line has gone beyond that part, so I can erase that line. Again, this part and this line from the previously drawn top view is going beyond that part. Okay, but now if you see this line is nothing but this dotted line which we have marked to mark that height, to make the closed shape. But if you see, this inclination is continuous throughout. So if you see this plane, this inclined plane is starting from bottom to top, and it is a continuous plane. So I will not see the intersecting line here, because I'll be able to see your intersecting line when two planes are inclined to each other and intersecting. But here they are not intersecting, and it is a continuous plane. So I'll not be able to see a separate line on that plane because it is a continuous plane. Obviously, to divide that into equal that same height, we made that extra construction which was not visible in front view. So that was our assumption. So, and if you see here, that as assumption initially was not there, so we are erasing it. That's why we are getting the continuous plane. Now, after reaching the topmost to this height, now your solution is complete. Now you can just keep the final view and erase the rest of the lines. You can erase that box also. The part of the boundary of the box which is not the part of that object can be erased, and those projectors initially drawn also can be erased. So now I'll decide the final view and make it dark. So if I make this dark, it will complete the solution. So first I'll erase those unnecessary lines. And I'll make the lines dark again, which are visible to the observer. Now this method can be followed when front view and side view is given, because we are going height by height. By dividing those views, front view and side view, into small parts of equal heights, and then completing the isometric projection for those parts, and then combining all the parts, we will get the final view, isometric view. So now after drawing all the parts and combining them, I'll be able to make the entire object dark. So initially while drawing, if you are sure that line will be entirely visible, then only make it dark. Remaining lines, if you are doubt whether after drawing the next part will it be visible or not, so keep that initially light, because after placing the part of maximum height, some part of the initially drawn height may not be visible to the observer. So you have to keep that in mind. Now after considering all the lines, we are getting this way. Okay. Now again, we can check the solution by referring to those views again. So as we own the knowledge of orthographic projections, so if the reverse question is asked, like draw the orthographic projection for this view, so you will check the front view and top view, so you can verify your answer. you can see here, since it is on the boundary, so I'll get a vertical projection. So which is I'm getting here. Then again this view, this entire thing is here. Again this trapezium is seen as inclined plane. Okay. Again this entire thing is seen as an inclined plane, but if you see the front view, it will be projected on a vertical plane, which is this plane, side plane. Okay. So this completes the solution for this particular problem. No need to give the dimensions, okay, in isometric, but be careful while measuring the box size, because if you draw the box with the wrong size, then you will be stuck in the solution. Okay. So you need to follow the same procedure for all the problems in which front view and one of the side view, either left hand side view or right hand side view, will be given. Again, if the problem is given for front view and top view, then same method can be applied, but there the common dimension will be length instead of height. So we can follow the same method, taking the parts of equal length and drawing the three-dimensional view for those small parts of equal length, and then combining the final view. Okay. Now, in addition to this procedure, now here there is no circular curved portion or circular holes. It is just made up of number of planes. So we will see in those particular problems, if circular holes or curved surfaces are there, how to draw the isometric projection. So for this, but this is the generalized procedure which can be followed for any problem. Okay. And along with this procedure, you need to have some imagination power, because everywhere this procedure may not be followed. So in some up to 20%, 80% this can help, but up to 20% it needs your imagination. Again, by practice you can master this isometric projections.